Okay, we are going to look at simplifying some trig identities, and I've included some of the common identities that are used, the Pythagorean identities and these quotient identities off to the right side. So let's start with this first one. Tangent theta plus cotangent theta times tangent theta. So I'm going to do a few things with this first step here. I'm going to use the distributive property and multiply both these terms by tangent theta. The other thing I'm going to do is I'm going to rewrite cotangent theta as 1 over tangent theta. So this becomes tangent squared theta, and then this will be 1 over tangent theta times tangent theta. So these two cancel out. This leaves me with tangent squared theta plus 1, which you can see is this second trig identity here. That's going to be secant squared theta, and that matches up with h here in our list. Moving down the line here, we've got cotangent theta plus tangent theta. Again, I'm going to rewrite 1 over cotangent theta. 1 over cotangent theta is 1 over tangent theta. And what I've created here is I've created a couple fractions that add together. The way we can simplify those is to get a common denominator. So my common denominator is tangent theta. So I'm going to multiply this by tangent theta over tangent theta. And this gives me 1 plus tangent squared theta over tangent theta. Well, we already know 1 plus tangent squared theta is secant squared theta. This secant squared theta, I'm going to write that as 1 over cosine squared theta. And then my tangent theta, I can rewrite that as sine theta over cosine theta. To divide fractions, I'm going to multiply by the reciprocal. So this will be cosine theta over sine theta. One of these cosines cancel. So 1 over cosine theta is secant theta. And 1, there's a 1 left here after I cancel out this cosine theta, is cosecant theta. And I can see that that matches up with J. Okay, I've gone and I've replicated this board over here to give myself some more room to work. So now let's look at number 3. So cosine squared theta, I'm going to rewrite secant squared theta as 1 over cosine squared theta minus 1. So distributing this out to get rid of the parentheses, I get 1 minus cosine squared theta. And this is actually this first Pythagorean identity here. If I subtract cosine squared theta from both sides, I can see that this equals sine squared theta. So that is D here on my list. Moving on to 4 here, I'm going to rewrite this cosecant as 1 over sine theta over 1 over cosine theta. When I divide fractions, it's multiplying by the reciprocal. So this will be cosine theta over 1. And then when I multiply these across, I get cosine theta over sine theta. And that is this quotient identity here. So this is cotangent theta. And that is going to be equal to B on my list. Let's go to board 3 for my last one here, number 5. Secant theta, I'm going to rewrite that as 1 over cosine theta minus cosine theta. So when I have subtraction, the way to do that is to get a common denominator. So I'm going to multiply this by cosine theta over cosine theta. So this gives me 1 minus cosine squared theta over cosine theta. I know cosine squared theta by this Pythagorean identity. 1 minus cosine squared theta gives me sine squared theta. So if I split this sine squared theta into sine theta here times sine theta, and then cosine theta, I get sine over cosine is tangent theta, and then this stays as sine theta. So that is going to be equal to F here on my list.